So, when we think of AI assistants, we often picture a simple back and forth chat. But what if you need to do really complex, multi step research? That linear model just breaks down.
It absolutely does. That's why we're diving into building a proper deep research assistant using LangGraph and MCP. This isn't just a chatbot, it's a stateful agent that connects to multiple specialized server zone for its own memory with vector storage, and another, the Firecrawl server, for scraping the live web.
And LangGraph is the brain of this operation?
Exactly. It's StateGraph manages the entire flow. It's not a straight line. It's a web of conditional logic that decides what to do next based on the conversation history and what tools it needs. This graph-based approach is what makes it so powerful for complex tasks, allowing the assistant to remember context and adapt its actions dynamically.
Okay, that makes sense. But what really stands out to me is the idea of user control. How does a user actually direct this complex process?
This is a key design choice. Instead of trying to guess what the user wants, the system exposes control through simple meta commands. You can literally type @prompt.name to load a specific thinking process, or @resource.uri to feed it a specific document. It puts the user in the driver's seat.
I see. And what about something like Retrieval-Augmented Generation or RAG? Is that always running?
That's another great point. No, it's not. RAG is treated as just another tool in the toolbox. The agent decides if it needs to retrieve information to answer a question. It's not a fixed mandatory step, which makes the whole system much more flexible and efficient.
So, LangGraph acts as the orchestrator, managing the complex state and branching logic, while MCP provides the structured library of tools and prompts, and RAG is just one of those tools. This modularity seems critical.
It is. The entire architecture is designed around this idea. Each MCP server is like an independent specialist, offering up its unique set of tools and resources. This makes the whole ecosystem swappable and scalable.
You mean I could add a completely new capability just by plugging in a new server?
That's the beauty of it. You just add the new tool to a server, and the agent immediately knows it's available. The research assistant isn't a closed box. It's designed to grow and incorporate new data sources or functions over time, which is huge for its long-term value.
So the MCP server structure is really the backbone for scaling this up. For anyone wanting to try this, what are the practical first steps to get a project like this off the ground?
The setup involves two main parts. First, you need Node.js version 22 or later to install and run the pre-built Firecrawl MCP server for web scraping. You can run it locally or connect to one that's hosted elsewhere.
And the second part?
That's the Python project for the agent itself. The code is already provided, so you just set up your Python environment and run a single command.uvsync to install all the dependencies. The README file walks you through it.
Got it. So it's a dual platform setup, Node.js for the Firecrawl server and Python for the agent's core logic. Getting those two environments ready is the foundational step.
Right? Once that's done, you have the complete blueprint. LangGraph's StateGraph orchestrates the complex workflow. MCP servers provide that crucial modularity, and direct user control via meta commands makes it a truly interactive tool. You're not just using an assistant, you're actively guiding it.